everyone. This time we're going to be doing example 9-18. And this time we're going to be doing a slightly different kind of problem. So what it says is a force of 6,700 newtons is applied to a steel wire that is 7.5 meters in length. So it's 7.5 meters long, and it's got a force of 6,700 newtons. 6,700. Let me get my pen to work a little bit better. $6,700. There we go. Newtons. The tensile stress in the wire must not exceed 138 megapascals. Okay. So stress max is equal to 138 megapascals. And the total elongation must not exceed 4.5 millimeters. So delta max equals 4.5 millimeters. So we got two conditions here, and we're going to hit one before we hit the other. They're most likely not going to happen at the same time. So we're either going to hit the max stress or the max elongation. We will probably not hit both at the same time. Compute the required diameter of the wire. Neglect the weight of the wire. And it says to use a modulus elasticity of 207,000 megapascals. A proportional limit of 234 megapascals. Okay. So E equals 207,000 MPa. And the proportional limit is equal to 234 MPa. Okay. So we need to find the required area, or required diameter of the wire. So we're going to try this for both ways. We have two ways of finding this area, and one of those areas is going to be smaller, and that's the one we're going to have to one of those areas is going to be smaller, and we won't use that one. We have to use the bigger area because we need to make sure it passes both conditions. Fails another one, it fails. So let's do that for stress first. So stress is equal to our load over my area. I'm solving for the area. So area is equal to stress, the load divided by the stress. And if I plug this in, what I get is that it's 6,700 newtons. Over 138 megapascals, or 138 million, so times 10 to the 6 newtons per meter squared. And what that will give me is it's going to give me, actually, wait a second, what am I doing right here? So what happens when I start looking at the book instead of just doing it normally? Remember that 1 megapascal is equal to 1 Newton over 1 millimeter squared. So I'm just going to keep it in megapascals and realize there's going to pop out in millimeters squared to make it easier for myself. So 138 megapascals. There we go. That's going to be much easier math. And this comes out to be 48.6 millimeters squared. Okay, this is the area due to just looking at the stress, okay? That stress is going to require that area. However, we have a second way of looking at this. We can also use our elongation equation. So delta is equal to the load length over the modulus elasticity times the area. And we can solve to get that the area is equal to the load length over E times delta. And so let's see what this area comes out to be. If I plug all the numbers in here, quite a few of them, 6,700 newtons, 7.5 meters, all the way over 4.5 times 10 to the negative third, and 207,000 megapascals. Okay. I also need to change this, realized here I need to convert this to millimeters if I want everything to work out nicely. So we'll make this into millimeters. Gotta make sure I do things right. 4.5. And this right here, I'm gonna multiply by 1,000 to get it into millimeters as well. There we go. And what I get is I have an area that's equal to 53.9 millimeters squared. Okay, so what this tells us is that this is my limiting condition right here. This area will be required. I need to use the bigger of the two areas to be able to make sure that both conditions are met. This area will support the max stress, and it will also keep from stretching more than the max elongation. So now I just use the area of a circle to figure out what the diameter is. So the diameter is going to be related through this equation. I have the area of a circle is equal to pi over 4 d squared. And so then if I solve, what I get is that d is equal to the square root of, make sure I write this out correctly, 4a over pi. There we go, that should have worked correctly. Yes. And if I plug everything in, I get that the diameter needs to be 8.28 millimeters. Now, I can go ahead and stop there. And you might be wondering, like, wait a second, what about the whole proportional limit? Why didn't you check it? Well, go back here and look. Do you see these two values it gave us? It told us that the max stress it's going to be having is 138 megapascals, and the proportional limit was 234 megapascals. We're never going to reach that, so we don't even have to test it. This diameter will make sure that we don't breach the proportional limit because our max stress is much less than our proportional limit stress. So we are completely good there. Okay, with that, that's the end of this problem, and I'll see you in the next example. Have a great day.